Problem number 4, a steel propeller shaft is to transmit 4.5 megawatts at 3 Hz without exceeding a shearing stress of 50 megapascal or twisting more than 1 degree and a length of 26 diameters. Compute that propeller diameter Fg is equal to 83 gigapascal. So from the idea of the power transmitted by the shaft, we have here power is equal to 2 pi Tf, right? Wherein this T here is the torque, where F here is the frequency, and P is the power in watts. So since we know that the power here is equal to 4.5 megawatts, and we convert that into watts, and we have here 4.5 times 10 to the 6 watts, since mega suggests times 10 to the 6. This is equal to 2 pi multiplied by the torque, and the frequency here is 3 Hertz. So we have 3 Hertz. So solving for the value of the torque, we have 4.5 exponent of 6 is equal to 2 pi x times 3. Shift, solve equals, and that would give us 238,732.41 Newton meter. So that is 238,732.41. This is Newton meter. Now, if we are going to compute for the diameter based on the maximum allowable stress, and we have here the maximum allowable stress is equal to 16T over pi d cube. And since given here in the problem, the maximum stress is limited to 50 megapascal, then we have here 50 megapascal is equal to 16. The torque here is expressed in Newton meter. So since what we want here is Newton and mm, so we convert this into Newton mm. So this would be 238,732.41 times 10 to the 3 Newton mm. Why times 10 to the 3? Because we converted the meter into mm. So we have here pi over diameter cube, and we now compute for the value of the diameter based on the maximum allowable shearing stress. So we have 50 is equal to 16 times 238,732.41 exponent of 3 over pi times diameter cube. Shift, solve equals, and we would have 289.71 mm. So this is 289.71 mm. Now we will compute for the diameter d based on the maximum angle of twist. So we have here based on the maximum angle of twist. So since in the problem we have here the maximum angle of twist is limited to 1 degree in the length of 26 times diameter. So we have here the angle of twist is TL over JG. So we have 1 degree here for the angle, and we convert that into radian. So we have here pi radian over 180 degrees is equal to the torque, that is 238,732.41 times 10 to the 3. We convert this in Newton mm, multiplied by the length. So according to the problem, the length is 26 times diameter, so it is 26d over the J, that's the polar moment of inertia, and we have here pi diameter to the 4th over 32. This is the formula for the polar moment of inertia. And we have the G, that is the modulus of rigidity, which is limited to 83 gigapascal. So we have here 83 times 10 to the 3 megapascal. So computing for the value of the diameter D, we have here 1 times pi over 180 degrees. This is equal to 238,732.41 exponent of 3 times 26 multiplied by the diameter over pi. Diameter to the 4th over 32 is multiplied by 83 exponent of 3. Shift, solve equals, and we have the diameter equal to 352.08 mm. So we have here 352.08 mm. So if we are going to compare between the two diameters, as you can see, if we are computing for the maximum load, the maximum torque, we go with the lowest value. Now in here, for the safe value of diameter, we would go with the highest value, because the larger the diameter, it is more safe. So therefore, the answer is equal to 352.08 mm.